So thank you for the introduction as well. So as mentioned before, my name is Folger. I'm a tech lead in N26, working in the software industry for the last 13 years. Specifically in N26, I've been working for the last 3 years. And in these last 3 years, I managed to be working as both as a software engineer and as a tech lead for 4 different teams. So today is all about sharing our story, sharing what we have done in this time, right? How did we manage to get where we are, and our story as a cloud-first bank. Okay, for those of you that are not familiar with N26, we are a German-based mobile-first bank. So mobile-first is really important. So we don't take mobile as something that we build on top of our services, but we really think through our products to be specifically tailored for the mobile experience. This means that we look at banking problems from a different perspective. Our mission is to change banking around the world and is to give or empower people to bank in their own way. We offer you a simple promise that is a new approach to banking, focusing in providing the best digital experience at the best price. We are not a tiny bank, not anymore. We are currently available in 26 markets and just in the Europe area, plus the US. And we are already processing more than 1.6 billion euros in transactions across 4 million customers. And for the next year, we plan to expand our operations to Brazil and more markets to come. A really great example of our promise is one of our latest product, Spaces. We know people need different spaces to manage money. So we make managing money simple through an intuitive interface so that you can organize your money in the best way that you find. But I'm not here to talk about our products. I'm here to talk about our technical journey, right? So let me give you some introduction to our technical numbers. N26 is 100% hosted in the cloud, and we started with this from day zero. Our tech organization is working in cross-functional teams, and each team is responsible for a subset of microservices. This subset of microservices normally are trying to tackle certain specific features for our customer bases. We deploy all these set of microservices around 300 times to our production environments on a weekly basis. But you might wonder how, right? How did we get to manage these numbers? Which kind of steps did we take to be where we are? So this is what this talk is about. I want to talk to you about what I believe is the digital transformation that we went through. I like to split this journey in 3 stages, being each stage a characteristic moment on the history of N26. The first stage is what I call growth, right? The main goal of the growth, obviously, is to deliver more features and faster, right? So the end goal is to have a happier customer base. So for this, let me take you back in the past. So what happened 3 years ago? This is the moment in which I joined the company. So we recently got our banking license. So this means that we moved from using a partner bank, which in this moment was Wirecard, to hold our own banking license. So this was a huge step for N26 because we managed to cut our costs for like 70% by having our own infrastructure for our banking operations. So we went through a huge migration from using a banking partner to hosting it ourselves. At this moment, we were like really low in processes because we were just like getting into the vibe of being a bank, right? So we were mostly doing face-to-face communication and alignment. The company was not that big, so we don't really need like a strong kind of communication channels or anything. So there was almost no enforcement on guidelines, but it was mostly informal agreements. At this point, one engineer was taking care of, in average, 3 microservices, which is like a really high number. So it was like a really small family, right? So we really tried to have engineers that were fully empowered to drive features from end to end, from being really good at the discovery phase, being really good at discovering what the customers needs, being really good at architecture decisions and implementing them and delivering to production. It was really easy to collaborate. As I mentioned, engineers had full ownership, and one of the most important characteristics of engineers in this stage was that they were like super engaged. Our engineer, let's say, average age was around 20, 25 years old. So I remember when I joined the company, I felt like, oh my God, I'm one of the oldest person in this group. So it felt like a really a teenagers group or something. But they were like super competent and super motivated to learn new things, to experiment. They were not afraid of making mistakes. They were not afraid of asking questions or to learn from somebody. So this we take it really seriously during our recruitment process. We wanted more people that have or share this engagement, let's say at this stage, because we really want people that were pushing the boundaries of delivery. So the teams were fully autonomous. This means that at this point, let's be honest, like, there was not clear, let's say, product requirements to the point that somebody can just go there and implement it from what it was written in a document. There was not even the document itself. So it was mostly somebody telling you, oh yeah, we need this feature, and then figure it out how to do it, right? How to implement it. So this person really need to have like really good communication skills to be able to make these features happen. The other part, as I mentioned before, the team was relatively young, and N26 is, in a way, using always edge technologies, right? So what is the problem with that? That all of those edge technologies require certain level of expertise, which we didn't have. So we really needed to find out ways of kind of removing that gap in between having highly motivated people and having highly competent people, which is entirely different. So I'm going to tell you how we did that. Another of the challenges is obviously in this growth stage is that you want to deliver products, right? So you want to make sure that you have really great features delivered to your customer in the fastest way possible. So that's why we took over the decision of like running entirely on the cloud and to relegate or delegate as much as possible to service providers such as Mambu and others, right? So I guess you are familiar with this matrix here. So on my right side, you have the on-premises. This means that you host your own servers, you configure your own servers, you do everything on your own, and these have a high operation cost, right? In the other side, you have the SaaS lane. This means you get software as a service, so you don't manage anything, you don't configure anything, everything is provided by somebody, right? So at this stage, we try to stay in the PaaS and SaaS area, right? Because we didn't want to reinvent the wheel. We didn't want to be revolutionary in areas that were not our main characteristics, right? So we really tried to use as much as possible that from the things that were already provided from the market. So in that sense, for platform as a service and software as a services, we were using Mambu, we were using AWS, we were using Jira, and these ugly logos is because security made me remove all the tools that we are using for logging and monitoring, but we are relegating this as well for other third-party applications. So why is this important? Because as we grow, as our customer base grow, our partners grow with us. So let's say as of today, we handle more than 20 million transactions per day. Mambu can handle that for us. We don't really need to care about scaling our ledger solution because they will do it for us. So how to bridge that gap that I mentioned early on between having people that are highly motivated and people that are highly competent. So we needed to train our engineers and to make sure that they have enough time to learn those skills that they needed to learn. Obviously, we have some engineers that were already well seasoned on the specific topics that we were handling, but that was not 100% of the cases. So for that, we have our experimentation and knowledge sharing culture. The first activity that we do is called GSDD. It's called Get Stuff Done Days. And this is to avoid any kind of meetings during 2 days, every 6 weeks. In these 2 days, you cannot go to stand-ups, you cannot go to planning, you cannot be invited to any meeting, you cannot be requested anything. So this time is for engineers to innovate, to experiment, to discover, and to learn something that they really want to learn. Examples of GSDDs is people joining together, front-end engineers, back-end engineers, security engineers, a product, for example, do a hackathon in 2 days and have a product deliver end-to-end as a proof of concept within the company. Or maybe you can just try it out this specific technology that is really hype in the market, but you don't know how will that work with your specific projects, right? So you really can use this time to the best that you can do, provide the most value for N26. The second is about lightning talks. So lightning talks are knowledge sharing sessions that we run on a weekly basis for something like between 45 minutes to an hour. In these lightning talks, people are encouraged to share the knowledge that they acquire, for example, during the GSDD days, or maybe a new technology that they are trying on their own specific teams, or maybe a success story about something that they tried out on their teams, or maybe something that they are just working on their personal projects, right? So the idea here is that the people that have the most knowledge can share the information with the people that have the least knowledge, right? So in that way, you close that gap. So that was our growing stage. As I mentioned, the main goal was delivery. Don't do things that you are not the expert in doing, right? If you can delegate that to others, then do it. Don't try to reinvent the wheel, and try to focus on your customer needs and the customer experience. In the scaling phase, after we managed to roll out a group of like successful products, and we managed to get some customer engagement into our product, and obviously we nailed down a huge funding round. So now we need to scale the organization, right? So now we went to the second stage. So the main focus on the scaling is to multiply the engineering seat that we created during the growth area, to optimize processes, and to work on continuous delivery. What were the challenges, right? So the challenges were, now we have more money, now we have more marketing. So this means we're gonna have more users. We're gonna roll out in new markets. Obviously, that brings more users as well. But at the same time, because now we are a bank and we are popular, this put us as a target for bad people. So we need to improve our security as well. And at the same time, regulators are going to be interested in us. So they're going to try to run more frequent audits. So we need to work in compliance as well. And because we need to scale up all of our engineering groups, one location was not good enough. Let's say we couldn't staff all of our teams just with the Berlin offices. So we needed to roll out new tech hubs. In this case, for this stage, it was Barcelona and New York City for the US launch. So for those of you that doesn't know, hypergrowth means that your numbers just go crazily high on hiring. So the main focus on this stage is that we were working a lot on boosting our technical brand. So for boosting our technical brand means that people look at N26 not just as N26 being a really nice company that provides really good user value, but something that is super attractive for engineers to be working on, right? So we wanted to share our story. We wanted to share which technologies we were using. We wanted to share which practices we were using. And we achieved that by writing articles, going to conferences, speaking and networking in different technical related topics. So this attracted a lot of talent, let's say, into the organization. So we almost tripled the amount of engineers. So we went from having something like in the early age when I started, it was like 100 between product and tech. And currently, we are more than 500 something in product and tech. In 1 month, we tripled the number, right? So just imagine that. Just imagine that you are working on a team that only have 2 engineers, and suddenly you have 8 engineers. So this, imagine just how do you manage the onboarding process, how do you manage the operational costs, how do you manage people, being productive after such a big number of people comes in. So you no longer know everybody, right? So before, as I mentioned in the grow area, face-to-face communication was possible because there was a limited amount of people, so you knew everybody. You knew who was working in what project. You knew who was responsible for that specific feature. Now you don't even know that those features are being built in the same application that you work for. So we needed to improve on onboarding process. We needed to improve in our communication practices. We needed to disperse our engineering principles or define what were our engineering principles, which I'm going to talk to you a little bit later. And we needed to optimize our delivery pipeline so that we can continue delivering fast while keeping security. So the first action that we took was company onboardings. So we group all the disciplines and we create company-wide onboardings for topics like backend infrastructure, product trainings, quality trainers, agile culture, SRA, software reliability engineer, so mostly development operations, and security. And the goal is to share our best practices about testing, about agile culture, the importance of security, and how the whole infrastructure in N26 is set up. But that's not enough, right? So you now have a global overview on how N26 works. Now you go to a team, and you need to know how that specific team works. So that's where team onboardings work. So team onboarding try to bring knowledge about the domain specific of that team. So what we usually do is we take one representative from the team and we draw in the whiteboard what is the architecture of the microservices that are behind the features that the team is taking care of. And we always try to pick somebody else to explain that feature, right? So these have 2 purposes. One, to make sure that everybody shares the same understanding about the architecture of the application. And second of all, obviously for the onboarding. The third one was the body system. So as I mentioned early on, we have the situation in which you have a group of 3 engineers, now you have 8 or 9. Obviously, if you have one single person taking care of the onboarding of 6 new engineers, and that person still needs to do their own like day-to-day activities, that doesn't scale, right? So with the body system, we take one person and we assign it to a new joiner, and that person takes care of the whole onboarding journey of the new engineer. And this could include just helping them to with the setup configuration for their machines, or for some of the cases, most of our engineers are coming from outside of the Eurozone. So this means that the onboarding body can help them to navigate through the whole country bureaucracy, visa processes, apartment searching, and whatsoever. But at the same time, this person will help you to do some pair programming sessions, or even just to have somebody to go for lunch, right? So when you join to a new company, everything is new. You don't see really familiar faces, so it's really good to have somebody that is already from day one dedicated just to make sure that you have the best experience. The second, or the fourth one, is to have a target operating model. So what we are looking here is now we have nine engineers, right? So we need to give those group of engineers a purpose. And obviously, a group of 9 engineers doesn't really work well because the more people that you have on a team, the harder the communication it becomes, right? So the idea in N26 is to have really a small teams so that the communication, let's say, lines are the least as possible. So for backend exclusive teams, we think that something like 2 to 4 engineers is a good number. And for cross-functional teams, it will be something between 6 to 9. And this includes backend engineers, Android, iOS, quality engineers, tech leads, and product managers. So segments is the way that we operate. So we have the company, let's say, and the company is divided in 6 segments. I'm just going to put the example of the segment that I'm working on. So I work on the activity segment. We drive engagement and use of the application in general. The activity will be the segment. The segment is subdivided in groups. One group, for example, will be early engagement. This means once the users create the account and did the first transactions, what can we do to make this user to be engaged with the app? And then within that team, within that group, you can have multiple teams tackling specific features, right? And the idea of this is that because you cannot replicate the same culture that you had when the company was really small at the startup level. Now the company is huge. The company have 1,500 employees. So the idea with this is that each segment, let's say, behaves in the same way that a startup will be. So with a smaller scale, with a smaller number of members, with less communication, with less alignment with other segments, let's say, with less coordination and with more autonomy. And this was really good for us. By rolling out the target operating model, we managed to have teams dedicated to specific needs of our customers. So you can have teams that are trying to target feature specific or market specific needs, right? So in this stage, for example, we roll out our first non-Euro accounts. For those of you that use N26, N26 within Euro provides a Euro account. But in the UK, for example, we have a pound account. And for the US, obviously, we have a dollar account. So this means 3 different currencies. This means 3 different banking regulations. And each, let's say, banking market have its own kind of specific in terms of like what needs to be done in compliance, security, and privacy in general. We have more than 10 payment schemes, and each market will have, let's say, for example, for Germany or for Europe, we have SEPA instance, and others, and for the UK, we have another ones. And at the same time, we have 4 different locations. So the idea of target operating model is that because the segments are entirely independent, you can have a tech hub in a different country that doesn't need to, or that needs to communicate with Berlin the least as possible, right? The same with the US, right? US have a different time zone than Europe. So if you will need to have some coordination between US and Europe, it will be really hard because the overlapping hours are like only 2 hours a day. So the aim for us, it was to have the speed of a startup, but at the same time to keep the security of a bank. As I mentioned before, so N26 is a German bank, right? This means that we have a banking license, and this means that we are heavily regulated and controlled. So many people will think that having this in place will slow down any startup, right? So that was the main challenge for our engineering teams, to be able to continue delivering as fast as we were, but at the same time to do it to the standards of security that were required. So let me give you an introduction on how do we solve that. So we have a clear definition of engineering principles, and this is what we call the 5S. So when people adopt a new practices or when they try a new process, we challenge people to live to all of those principles and to take decision based on those principles. So we are not an ad tech. So we, in our 5S principles, obviously include security, scalability, stability, speed, and simplicity. So these principles are intentionally not prioritized, so there is nothing that is on top of the other. So the idea is that engineers will have them all in mind at the same time when they are taking decisions, right? Obviously, when you want to have like higher speed, then obviously you are sacrificing from the other corner, right? So when you pull one side, the other side moves. So you need to find what is the right balance for keeping all of them together. A great example of our 5S principles are continuous delivery and infrastructure as code. So let me talk to you a little bit about continuous delivery. So continuous delivery means, as the name says, that you continuously deliver software to your production environments. So many of you probably use continuous delivery already, but from my experience and from working in different companies, not many of those companies were really following to the letter, right? So how does it work? When our team makes changes, we follow a 4I principles. So this means that every single change is co-reviewed by a peer. Once this co-review process that normally tries to cover like code quality, that the feature is properly tested, that is scalable, that is following all the, let's say, main engineering principles that we follow, then this gets merged to the master branch. And when that gets merged, our CI/CD pipeline kicks in, and we run these specific versions of the application in every specific environment. So we run in 3 different environments, so development, pre-production, and production, and we do it across multiple regions as well. So we do it for Europe, we do it for the UK, and we do it for the US. So whenever an artifact is deployed in a specific region, a set of automated tests are run, and these include unit integration tests, performance tests, end-to-end tests, and other kind of testing. So only when all of those checks pass, the artifacts move to the next stage. For this, we use canary releases. So this means that we have multiple instances of a service behind a load balancer. So when we want to roll out a new version of the application, we take one of those instances out of the cluster, we update or we upgrade the version of the software of that instance to the new version. We run a set of automated tests, and only when those automated tests pass, we put that instance back into the cluster, and we repeat the same process for the rest of the instances. And in that way, we manage to have a deployment that the customers are not really aware of it, following a zero downtime principle. So what's really interesting about this approach is that every deployment have an immutable infrastructure component, right? So no more that we have this snowflake service that nobody can touch because only that engineer that had been working for the company for 4 years knows what was installed in that server, right? Everything gets destroyed every time that we deploy and recreated from scratch. And because we capture snapshots, it's really easy for us when something goes wrong to go back to a previous version that we know that was working. What about infrastructure as code? Although you can use closed services through a web interface by clicking around. So if you go to an AWS console, for example, you can create EC2 instances just by clicking around in the web interface or the web console. Infrastructure as code use a different approach. The infrastructure as code leverage on these public APIs that the providers give us and enable us to express everything from configuration, security, networking under the source control. So each change that we apply to our infrastructure is auditable, traceable, and reproducible. And obviously, because it runs through our continuously delivery pipeline, there is a set of automated tests that we run whenever we want to change something in our infrastructure. So there is no more manual steps. There is no somebody with a checklist making sure that all the checks were covered. Everything is automated. So operating infrastructure as code means also that we scale much better, right? So when you have more than 300 instances of a specific EC2 instance, it's impossible for one engineer to keep an eye on all the configuration, right? But when you express it as code, you multiply the capabilities of your engineering team. So you need less people to handle a higher number of services. So one person in our case can take care of 150 instances. So this really helps us towards our hypergrowth stage, because obviously when you have more engineers working on features, this means that there will be more new services created, new infrastructure require more deployments, more, let's say, requirements on logging, more like changes on provisioning and everything. So this means that because everything is part of the code, our engineers can handle a higher load of their services as well. And automation is much better than human checklists because obviously it prevents deviations. So there is no risk that somebody forgot to do something because everything is as part of the code, right? And a good example we have is our backup and recovery. Everything is automated and is controlled using the same kind of methods. So you might ask, how has all of that paid off, right? Do you remember Meltdown and Spectre? This was a vulnerability that affected almost all processors in the entire world, and this happened last year. So affected billions of systems, globally speaking, and there were many companies that were not able to update their service because we have this kind of a specific configuration that only works that specific server, that the engineer that did it no longer works for the company and nobody can change it, right? So let me walk you through how did it work for us. So on the January 3rd, Google announced it publicly that this vulnerability exists. In the same day, Intel confirmed that it was in fact a vulnerability. One day after, they announced a fix. Just one day after, Amazon published an update of the kernel. We updated our own base image for all of our instances inside our infrastructure, and we use our CD pipeline to test these changes across all of our environments and all of our regions. And in the same day, we managed to incrementally test it and roll it out to the entire N26 infrastructure. So in just a few hours, you can apply configuration to your entire ecosystem. So I guess doing this in a manual fashion will be a matter of like weeks. So after a few days that the Meltdown and Spectre was announced, we were confidently rebuilding our entire services and infrastructure with a critical patch applied. So our main goal was covered, which is we want to have the speed of a startup while still keeping the security of a bank. The third stage is called stabilizing. So in this phase, you want to have the calm after the storm, right? So you have a lot of people coming into the organization, a lot of change happening, a lot of like miscommunication problems, a lot of alignment problems because maybe one thing was working on something that another thing was working at the same time, or there was some priority conflicts. So this phase, the stabilizing phase, is basically to get back in track and try to tackle the impacts of hypergrowth. So the stabilizing phase focus in alignment, high availability, and minimizing risks. So for the alignment part, we did two specific initiatives. The first one being the RFC. I guess most of you are familiar with the topic or with the term RFC, is request for comments. And we use this to get fast feedback about the technical initiatives that we want to have in our organization. So why do we want to have that? Is to have some alignment between different teams on what we are working on. We want to have some early feedback about maybe architectural decisions that we are taking. When do we want to do this? We mostly do it before rolling out new microservices inside N26 ecosystem, or before doing a considerably big change within the infrastructure. And what is the purpose of it? Obviously, whenever you are doing something, you need to have a purpose, right? So you just don't do things for doing it. So the first one and the most important one is the problem statement. So what you're trying to solve with this solution. You need to provide stuff like what were the solutions that you evaluated, what was the selected solution that you picked, and an architectural overview of the solution that you want to implement. Normally, this process is rolled out within like main stakeholders of your service, and then afterwards roll it out to the entire organization. So this has been really successful for us because it really helps you to understand what the other teams are working on, and if maybe a specific service that this other team that works in a different country will be helpful for something or for a problem that your team is trying to tackle. And at the same time, if you are really making a huge mistake from the architectural point of view, you will get some feedback as well from more experienced other team members of N26. The second one is the tech radar. So the tech radar helps us to keep in line the knowledge that we are using. So as I mentioned before, we are using a microservice architecture. This means that in theory, every single microservice could have their own tech stack, right? So everybody could have a different language, everybody can use a different web framework, everybody can use anything that they want, right? And because engineers always are driven by hype, unfortunately, or fortunately, depending on your position, you don't really want your organization to become a chaos, right? So the tech radar was put in place to make sure that we stick to a set of validated technologies that we know that work well, and that we build expertise around those technologies. So a good example of it is that in N26 we only use Java and Kotlin. So Kotlin was lately introduced 1 year ago. But we really want to make sure that the process is structured and that we really know what we are taking, the decisions that we are taking. So let's say, for example, if you want to test a different web framework, we currently use only Spring Boot. But if you want to test a different web framework, you really need to express why do you need to use that web framework, right? And the answer cannot be it's just because it's hype, right? So you need to have a specific problem that you're trying to solve by implementing or by introducing a specific technology. And you need to really have understanding or what is the benefits behind that technology, right? So we always try to run this trade-off analysis on what are the benefits, what are the downsides, what is the implementation cost, what is the rollout cost, what is the migration strategy. All of that we have it in mind before actually rolling out a new technology. And by having this small subset of technologies, our teams can build on top of it. So they can, let's say, for example, do expertise talks in our lightning talks about how they have evolved their knowledge on a specific technology, or they can build libraries around it and build like good practices. So obviously this is not strict, like you can still change it, right? So we have a process to change things that are inside the tech radar. And the idea is that you need to provide a proposal, a proof of concept. And for this, you can use your GSDD, right? So during these 2 days, you can build a new service, for example, using that specific technology that you want to try. You can do the proposal. And then once that's approved by your tech lead, or you have an architectural guild, which is a combination of all of our tech leads in the organization. Once the tech leads approve, you can test that in a non-critical production service. And once you collect the results of your test, we can decide if that technology goes on hold or can be widely used by the rest of the organization. High availability. As I mentioned, we are a bank. I mentioned it multiple times because it's like what we normally listen in all of the engineering talks that we are in N26. So we really need to have a high availability. So by us not being available means that customers doesn't have access to their money, right? So this is super critical for us, and every second counts for us. So because we are doing, as I mentioned, more than 300 deployments per week, this means that things are gonna go sideways, right? There is no way to avoid incidents to happen. So you can work on trying to avoid them, but they will always happen, no matter what. So the best way to avoid incidents is by avoiding changes. But as we have been talking about this today, the only way to keep yourself competitive in the market is by having an ability to make changes faster. So that's not an option. So you cannot avoid the incidents. You need to minimize the time for you to react to those incidents. So we try to identify each of the phases of an incident into 4 parts. So the first one is the identification. This means you create a software change or something happening to your infrastructure that causes your service to misbehave. So how long did it take you from this was deployed until you find it out, right? So this is the identification phase. So now you know that something is wrong. How long does it take you from knowing that something is wrong until that you can diagnostic exactly what is that is wrong? And then the third one is the fix. So how long does it take you to make an improvement in your code, either to roll back or to roll forward your infrastructure so that that is no longer impacting your customers? And for this, we really ask teams to have all that is required in place, like automated testing to make sure that we can make change reliable without changing any business logic, right? That your code is to a good level of quality so that, for example, it's not like a highly coupled application that making changes is nearly impossible. And the last one, but not least, is how much time, once you have your fix done, takes you to deploy to all your environments in the production environment. So we try to optimize in all of these 4 phases. Whenever we see that there is a high accumulation in time on a specific phase, we try to optimize, and we do this by running postmortem. So the first problem that we have during the scaling phase is because we have a lot of engineers that were not aware of how the incident process or the incident response process should work. Incidents were happening, but nobody was really working on improving it so that those incidents doesn't happen again, right? So what we did for that is that we try to promote a post-mortem culture. So whenever there is an incident, what is an incident? An incident not necessarily means that users are impacted, but if there is a degradation on a service, that counts as an incident as well. So whenever there is an incident, we run a meeting, which is called a post-mortem. And the goal of this meeting is to have 4 items covered. So the first one is the timeline. So what happened when, for example, which actions did you take? What did the on-call engineer did? What did they try? What did it work? What didn't work? The second one is you want to identify what was the root cause, right? So the idea is that you clearly know what something went wrong. So that's the root cause. Then the resolution actions, which is like which action do you take for these incidents to go away. And then the last one is the remediation action. So which actions are you taking to avoid that incident to ever happen again? Obviously, it's super important for us to minimize the risk as well. So we run something called threat modeling sessions. As we scale, the same problem of hypergrowth, we have more engineers, we have more features. Obviously, our security engineers didn't scale at the same, let's say, speed or pace that our engineering team did, because security engineers are obviously harder to find. So what we did is that we create a security champion program, and security champions are just normal engineers, either QA, backend, or frontends, that have a training on security, and they work directly on the teams on defining what are the security requirements that each of our application needs to cover. So we run threat modeling sessions in which we try to identify what are the potential improvement points from the security point of view that we need to have in our services before we roll that out into production. SLOs, so we need to have clearly defined non-functional requirements. And the idea is that for every services that we have, we can answer the question, is this service really working as expected, right? So the idea is that we can keep a track on these SLOs across time, and we use them as a way to continue improving. Observability, obviously, you want to make sure that your services logging is in place, that you have monitoring in place, that you have automated alerts, that you have traces to be able to follow a request across multiple microservices in a distributed system. And if you have time, or if you have the resources as well, if you can build machine learning on top of all of these tools to have an outlier detection, for instance. We advance as well on testing. So we continuously implement new ways of testing to have a better reliability on our services. So this means that we run performance testing on a daily basis for every service. So whenever you are deploying, we make sure that the new deployments still cover the same non-functional requirements that the system was designed for. We run penetrations testing from the security point of view. We run chaos testing to make sure that when something goes wrong, our services still behave in the way that they should. We run exploratory testings, and we run contract testing. So just to give you an overview of our lessons learned, you should adjust to your journey conditions, right? So depending on what are your main goals on a specific stage, you need to define which actions you need to take in order to adjust. Continuous delivery help you to deliver changes faster and reliable to your customers. Speed and security both are possible if you use continuous delivery and infrastructure as code to support it. And continuous improvement is required to keep a healthy production environment and a happy customer base. Thank you very much.